Hi everyone, today we're going to be doing lesson 6b.5, combining like terms. Our objective today is to be able to combine like terms to solve equations. Before we can start, sorry, I had a little situation here I forgot to talk about. Let's say we had Gail. She has 4 hair ties and 2 chapstick in her purse. Mary has 3 hair ties and 3 chapstick in her purse. What do they have all together? Well, if I asked you this question, you probably would not go, okay, we have 4, 5, 6, 7, 8, 9, 10, 11, 12 hair tie chapsticks, right? I'm just going to abbreviate that as HT for hair tie and C for chapsticks. They don't have 12 hair tie chapsticks because hair tie chapsticks aren't a thing, and if they were, that would be kind of gross. So, what do they have? They have 4 hair ties and 3 hair ties, so a total of 7 hair ties. I have 2 chapsticks and 3 chapsticks for 5 chapsticks. So that's what you'd probably tell me. They had 7 hair ties and 5 chapsticks. You wouldn't try to put those together because hair ties and chapsticks aren't the same thing, and we don't want hair tie chapsticks because, again, that sounds gross. So that leads us to our vocabulary today. What are some of the words we need to know? Well, first thing, let's talk about an operator. Operator, let me go to my little clicky thing. Operator is what you're doing to 2 things. In this case, we're adding. So addition is our operator. You could have subtracting, you could have multiplying, you could have dividing, you could have a lot of things. But in this case, addition is our operator. We already know what a variable is. A variable is that letter that's sitting there pretending to be a number. It stands in for a number. So x in this case is my variable. Now here's a couple words you might not be familiar with. Coefficient. That's a big fancy word, isn't it? Coefficient. Coefficient is nothing more than that number that is stuck to the variable using multiplication. It always comes before the variable, and they're put right together, 4x. So 4 is my coefficient. Another word you might not be familiar with is constant. Constant is a number without a variable. So in this case, 3. 3 is my constant. Now my last word is our most important word for today. It's our term. Oops, that did not want to get grabbed. Term. 4x is a term. 3, my constant, is also a term. Terms are the things that can be, they're either numbers, variables, or numbers attached to variables. They can be combined. So in this case, I have 2 terms. I have a constant, and I have a variable attached to a coefficient. Both of those are terms. That's an important word for today because our subject is to combine like terms. So in order to combine like terms, you need to know what a term is. So now that we know what a term is, we have we have the phrase like terms. Like terms are terms that have the same variable, or in some cases no variable, raised to the same power. Like terms can be combined with addition and subtraction. Unlike terms can't be combined with addition and subtraction. So if I went back to my previous example, these two are not like terms. Even though I have a plus between them, I can't combine them right now without knowing what x is. So these are unlike terms. This one has a variable, this one does not. In order to be like, they have to have the same variable. I'm going to go back to Mary and Gail. Hair ties and chapstick are not like terms. I can't put them together and call them hair tie chapsticks. I have hair ties and I have chapsticks. Those are unlike terms. So let's look at some of these examples. Are these like terms or unlike terms? I have 4x and 10x. Notice they have the same variable. They both have an x. The numbers don't have to be the same, but the variable has to be the same, and the variable has to have the same power. In this case, they both have a power of 1. When you have a power of 1, you don't usually put it, so it's invisible. So these are like terms because they have the same variable raised to the same power. Let's look at our next example. I have 3xy and 5y. Well, they both have a y, but this one also has an x, so they don't have the same variable. I can't add these and make it 8xy because this one does not have an x on it. These are unlike terms. My next one, I have 9x squared and 4x. This one has a power of 2. This one still has my power of 1, or my invisible power. So I cannot combine them to addition to make it 13x to the second power. So these are not like terms. Here I have 3 and 2y. This one has a variable. This one does not. I cannot combine them. They are not like terms. Now these two might look confusing. I have 2x to the second power, y, 3x, y to the second power. They have the same variables, x and y. I see a second power. So are they like terms? Well, in this case, the second power is on the x. In this one, the second power is on the y. So no, even though they look similar, they are not like terms. What about this one? I have negative 2xy and 3xy. This one has a negative. Does that make them like terms or not like terms? Again, you don't have to pay attention to the numbers. Look at the variables. This has an x and a y. This has an x and a y. They're both raised to the first power. They are like terms. And last, I have 2 and 8. Well, neither of them have a variable. Can I combine these through addition? Can I add 2 and 8? Absolutely. These are like terms. You don't need to have a variable on it to have like terms. Okay, now when you combine like terms, it's really important that you pay attention to the sign that's in front of each term. Now in this first one here, there is no sign. But remember, when we have a positive number, we don't put plus 8 in front of that. So this is just an 8. It's positive 8. And we're subtracting, positive 8x. We're subtracting 2x and we're adding 5. Do I have any like terms here? Well, I do. I have this 8x and I have this minus 2x. I can combine those using addition and subtraction. 8x minus 2x gives me 6x. Now I have this 5 here. Can I combine it? No, there's no x on it. So it has to say exactly like it is. So when I combine my like terms, I have 6x plus 5. Let's look at my next example. I have 4k plus 17 minus 2k. Well, do I have any like terms? Well, I have a 4k and I have a 2k. I have a minus in front of that 2k, so I'm subtracting the 2k. The 17 does not have a k on it. It is not a like term, but I can combine these two. 4k minus 2k leaves me with 2k, because 4 minus 2 is 2. Picture that if you had 4 k's in your hand and you took away 2 of the k's, you'd be left with 2 k's. And then don't forget, I still have this 17. This next one looks pretty confusing. It's long. Let's see if we have any like terms here. Well, I start with the 3a, so let's look to see if I have any other a's. I have 3a, I have a minus an a, And I keep going. I don't have any more A's. 3A minus A. Well, how many A's is this? Remember, when there's no coefficient in front of a variable, there's that invisible 1. So 3A minus 1A gives me 2A. See if I have any other like terms. I'm going to switch colors. I have 5B, and I have a minus 2B. Well, 5B's minus 2B's gets me 3B's. Don't forget to put the plus in between there. If you don't, you're going to be multiplying. 3B's. One more color. I haven't done purple. I'll try purple. I have 10, and I have plus 3. Well, 10 plus 3, I'm adding 13 more. So when I'm all done with this one, I have 3 terms, 2A plus 3B's plus 13. I can't combine these because they all have, these two have different variables. This one doesn't have a variable at all. Well, now we're going to solve some equations. Our steps are, if we can distribute, we're going to do that. This one does not have any distributing. Then we combine our like terms, then we solve. Since I don't have any distributing, I'm going to combine my like terms. I have 3x plus 5x. Well, 3x's plus 5x's, I get 8x. Then I have 7 minus 2. Plus 7 minus 2 is 5. So I have 8x plus 5. And that will give me 21. Now you might ask, why didn't I combine the 21? To combine like terms, they have to be on the same side of the equal sign. I can't combine it with this. Draw my lines down, solve it like any two-step equation. I want to get this 5, get rid of this 5. Opposite of adding 5 is subtracting 5. This cancels out. I'm left with 8x equals 16, because 21 minus 5 is 16. I'm going to divide both sides by 8. My 8's cancel out, and I'm left with x equals 2. I'm not requiring you to check all of these problems because they would get kind of long, but let's just do a quick little mental check up here. If x is 2, 3x would be 6, plus 7, plus, if x was 2, 5x would be 10, and then minus 2. Let's see if this adds up. 6 plus 7 is 13, plus 10 is 23, minus 2. That's 21. It did, it worked. So x equals 2. And I feel pretty confident with my answer because I did a quick check. Here's another example. Let's look for our like terms. Start with 7s. I always start with the one I see first. 7s, and I minus 5s. 7s minus 5s gives me 2s. Now I broke my rule and I used s as a variable. I don't like to do that because, you know, my s's and 5's look a lot alike. Okay, next I have a plus 4. Do I have any other numbers on this side of the equal sign? No, I don't. So I just have plus 4. And that has to equal 16. This one seems a lot easier than the previous one. Notice I didn't distribute. I didn't have any distributing to do, but I did combine my like terms, and now I'm going to solve. Draw my line down. Subtract 4 from both sides. Hopefully you're getting good at solving your equations by now. You've had quite a bit of practice. I have 2s. Try to make a really S-looking S. Maybe. Can look like 25 there, though. I don't like to use those S's. 16 minus 4 is 12. Divide both sides by 2 to get that S by itself. And I get S is equal to 6. Again, we could do a quick check. 7 times 6 is 42. Plus 4 is 46. Minus 5 times 6 is 30. Well, what's 46 minus 30? It's 16. It worked. S is 6. One last example. We need to have one that does have distributing, so we know that we need to do that first. So I do have distributing here. I can tell I have those parentheses right next to a number. I'm going to write down everything that's not related to my distributing. So I have my 16 equals 5y plus, now I distribute 2 times y. It's 2y. 2 times 1 is 2. There's a plus between it. So I'm done distributing. Now I can combine my like terms. Well, I have 5y and I have plus 2y. Well, 5y plus 2y is 7y. Then I have plus 2. I don't have any other numbers to add to that. Equals 16. Let's solve it. Two-step equation. Oops, that was a squiggly line. Turn my lines down. Subtract 2 from both sides. Remember, we always want to maintain equality. So what we do to one side of the equal sign, we have to do to the other. That cancels out. I'm left with 7y. 16 minus 2 is 14. Let's divide both sides by 7. And y will equal 14 divided by 7 is 2. I'll write this equation over here because I kind of have a lot of writing. 16 equals, remember 2 for y, 5 times 2 is 10, plus 2 parentheses, 2 plus 1 is 3. 2 times 3 is 6, plus 10 is 16. Quick check, but it works. Your homework's worksheet, combining like terms. If you're a distant learner, make sure you enter it in Backpacks and submit a picture showing your work. In school, you're going to bring your completed worksheet to class. You do not need to enter into Schoology. Into Backpacks. Have a great day. Talk to you soon.